Dear students, in previous video lecture we have seen some examples on DUIS rule 1. Now we will see more examples on DUIS rule 1. Next example, prove that integral 0 to infinity 1 upon x square log of 1 plus ax square dx is equals to pi root a for a greater than 0. Using this result, prove that or deduce that integral 0 to infinity 1 upon x square log of 1 plus x square dx is equals to pi. Write the given integral in the notation form. This function is to be integrated with respect to x. X is variable, a is parameter. So notation for this integral is I of a. Limits 0 and infinity are constant. So use DUIS rule 1. Differentiate on both sides with respect to a. Using rule 1, I of a becomes I dash of a is equals to the partial derivative of this function with respect to a. Here RHS becomes integral 0 to infinity the partial derivative of this function with respect to a. While finding the partial derivative of this function with respect to a, keep x totally as a constant. 1 upon x square keep as it is. Derivative of log of 1 plus ax square with respect to a is 1 upon 1 plus ax square, and derivative of 1 plus ax square with respect to a is x square, because derivative of 1 becomes 0 and x square is constant, so keep this at it is. So here x square and this x square will get cancelled. One function is left here, 1 upon 1 plus a square dx. Integrate this function 1 plus ax square dx with respect to x within the limits 0 to infinity. To evaluate this integral, use the standard integration formulas here. First of all, take a outside. This 1 becomes 1 upon a plus x square dx. Write 1 upon a as 1 upon root of a bracket square, and this will reflect into some standard formula of the form 1 upon x square plus a square, integration of this. So we observe that this is of similar kind. Integration of this is equals to 1 upon a tan inverse of x upon a. Instead of a, 1 upon root of a is there. So 1 upon a is the constant in this integration, take outside. Use this standard formula. Integration of this function with respect to x is 1 upon under root of a tan inverse of x upon 1 upon under root of a, 0 to infinity. This is equals to 1 upon a, this becomes into root a, tan inverse of, this becomes x into root a, and apply the limits 0 to infinity. Replace x by upper limit infinity, replace x by lower limit 0. So this 1 upon a and root a, one of the root a will get cancelled, 1 upon root a, tan inverse of infinity minus tan inverse of 0. We know that the value of tan inverse of infinity is pi by 2. So place this value here, tan inverse of 0 is 0. Therefore, this I dash of a is equals to 1 upon root a into pi by 2. Call this as equation number 2. But we want I of a. For that, integrate it on both sides with respect to a. So I dash of a becomes I of a. Integrate this function with respect to a. Pi upon 2 is constant, take outside. 1 upon root a can be written as a raised to minus 1 by 2. Integrate with respect to a plus some constant c. To find this value of c, place some specific value of a in LHS and RHS. Before that, find the integration of a raised to minus 1 by 2 dA. Integration is in front of you by using the rules of integration. So I of a is equals to pi by 2, a raised to 1 by 2 upon 1 by 2 plus c. So 2 will get cancelled. Pi into a raised to 1 by 2 becomes root a plus c. Therefore I of a is equals to pi into root a plus c. To find the value of c, put a is equals to 0 in LHS and RHS. Therefore I of 0 is equals to a is 0, first term becomes 0, is equals to c. C is equals to I of 0. You can find I of 0 by using the given integral. Since I of a is integral 0 to infinity 1 upon x square log of 1 plus ax square dx. So place the value of 0 here, becomes I of 0 is equals to 0 to infinity 1 upon x square log of 1 dx. But log 1 is 0. Therefore this integral becomes 0. So value of I of 0 becomes 0. If I of 0 becomes 0, c becomes 0. Use this value of c in equation number 3. So equation number 3 becomes I of a is equals to pi root a. That means I of a is integral 0 to infinity 1 upon x square log of 1 plus ax square dx. The value of this integral is pi root a using DUIS rule 1. Now using this we have to deduce one result, the second part of this question. Put a is equals to 1 in LHS and RHS. So this integral becomes 0 to infinity 1 upon x square log of 1 plus x square dx, and this is equals to pi. So this is the second proof of this question and this is the first part of this question. Next example. Prove that integral 0 to infinity e raised to minus ax minus e raised to minus bx upon x dx is equals to log of b by a for all the values of a and b greater than 0. That means for the positive values. If you observe the nature of the function here, this function is to be integrated with respect to x, and other than x, two variables are occur a and b. That means you can see that x is variable and a and b are the parameters here. So this question is with two parameters and one single variable x. To solve these questions, you can denote this integral either by I of a, or you can denote by the second notation by I of b also. So we'll consider that I of a is equals to this integral dx. Limits 0 and infinity are constant. So to evaluate this, use DUIS rule 1, differentiate on both sides with respect to a. R dash of a is equals to integral 0 to infinity partial derivative of this function with respect to a dx. While finding partial derivative of this function with respect to a, keep x and b totally as a constant. So integration of this function with respect to a is derivative of e raised to minus x with respect to a is e raised to minus ax, and derivative of minus ax with respect to a is minus x, keeping x as a constant. Here b is constant, x is constant, so derivative of this function becomes 0 and x is constant. Keep this as it is, integrate this with respect to x. Therefore I dash of a is equals to, take negative sign outside, minus integral 0 to infinity x cancel e raised to minus ax dx. Here integrate this function with respect to x within the limits 0 to infinity. While integrating this function with respect to x, keep a totally as a constant. So integration of e raised to minus ax is minus e raised to minus x, integration of derivative of minus ax, here minus a, apply the limit 0 to infinity. After applying the limit 0 to infinity to this function, this minus minus becomes plus, e raised to minus infinity minus e raised to 0 upon a. So e raised to minus infinity is 0, e raised to 0 is 1. So output is I dash of a is equals to minus 1 upon a. But we want I of a, so integrate on both sides with respect to a. After integrating I of a, this becomes after integrating I dash of a becomes I of a, integration of this function with respect to a plus some constant c. Integration of 1 upon a is log a plus c. Now we need to find the value of c here. So use some specific value of a. Here in this question your function is with one variable and two parameters. So you can use the other parameter as a substitution to find the value of c. Here we denote the given integral by I of a. So to find c, use the value a is equals to b. That means the second parameter for the substitution. So put a is equals to b in LHS and RHS. So this becomes here I of b is equals to, place in this original integral 0 to infinity a by b, so e raised to minus bx minus e raised to minus bx upon x dx. And if you observe, the numerator function becomes 0 because of the replacement a is equals to b. Therefore I of b is equals to 0. If a is equals to b, equation number 3 becomes I of b is equals to minus log b plus c. So I of b is 0 is equals to minus log b plus c. Therefore value of c is equals to log b. So place this value in the previous equation number 3. I of a is equals to, the value of c is log b. So minus log a plus log b. Therefore I of a is equals to log of b minus log a. Apply the rules of logarithm. I of a is equals to log of b by a. Therefore value of this integral I of a, 0 to infinity e raised to minus ax minus e raised to minus bx upon x dx is equals to log of b by a. Using this example, you can solve one more example of the same form. Prove that integral 0 to 1 x raised to a minus x raised to b upon log x dx. Again this function is to be integrated with respect to x. So x is variable and a and b are the parameters. So either denote this by I of a or denote this by I of b. Limits 0 and 1 are constant. Apply DUI's rule 1 and evaluate this integral and show that this is equals to log of a plus 1 upon b plus 1. Next question on DUI's rule 1. Assuming that integral 0 to infinity sin x upon x dx is equals to pi by 2, evaluate integral 0 to infinity 1 minus cos x upon x square dx. So we have to evaluate this integral, and while using this we have to use this result also, which is given in the question. So given that 0 to infinity sin x upon x dx is equals to pi by 2, this function is to be integrated with respect to x. So x is variable, a is parameter. Notation for this integral is I of a, 0 to infinity the function dx. 0 and infinity are the constant limits. So differentiate by using DUI's rule 1. Differentiate on both sides with respect to a using DUI's rule 1. So this is equals to I dash of a is equals to 0 to infinity partial derivative of the function with respect to the parameter a. Here while finding the partial derivative, you have to keep x totally as a constant. Derivative of 1 becomes 0. Derivative of cos is sine of ax with the negative sign, that means minus sine of x, so minus minus becomes plus, and derivative of ax with respect to a is here x. So write down this x here dx, and derivative of 1 becomes 0. So one of the x will get cancelled, dx. So I dash of a is equals to integral 0 to infinity sine of x upon x dx. Now if you observe this integral, we have to use the given data here in the evaluation of this integral. We have given that integral 0 to infinity sin x upon x dx is equals to pi by 2. So to reduce this into the standard form, use the substitution x is equals to t. Differentiate on both sides. A into dx is equals to dt. X is equals to t upon a, and change the limits also. So when x is equals to 0 in the substitution, t becomes 0. When x is equals to infinity, t becomes infinity. So this integral becomes 0 to infinity sine of t upon a, and dx is equals to dt upon a. So using all the substitution, the next step is here. This small a will get cancelled, constant will get cancelled, and this is equals to integral 0 to infinity sin t upon t dt. Now use this given result here. 0 to infinity sin x upon dx is equals to pi by 2. Only the variable is changed. Variables are immaterial in the definite integral, so you can use the value of this integral as a pi by 2. Therefore I dash of a is equals to pi by 2. Equation number 3. But we want I of a, so integrate on both sides with respect to a. After integration, I dash of a becomes I of a is equals to integral of pi by 2 dA plus c. Pi by 2 is the constant, 1 is left there, integration of 1 is a with respect to dA plus c. I of a is equals to this. Now we need to find the value of c. So put a is equals to 0 in LHS and RHS. Therefore I of 0 is equals to a is 0, first term becomes 0 plus c. Therefore I of 0 is equals to c. You can find the value of I of 0 by using the given integral, as I of a is equals to integral 0 to infinity 1 minus cos x upon x square dx. Put a is equals to 0, integral 0 to infinity 1 minus cos of 0 upon x square dx. Since cos 0 is 1, so 1 minus 1 becomes 0. Therefore the value of I of 0 is equals to 0. If value of I of 0 is equals to 0, c becomes 0, and if c becomes 0, this equation number 3 becomes I of a is equals to pi a upon 2. So therefore the value of integral 0 to infinity 1 minus cos of x upon x square dx is equals to pi upon a upon 2. Now try this next two exercise question on DOS rule 1. Prove that integral 0 to infinity e raised to minus x square cos of 2x dx. Here this function is to be integrated with respect to x. So a is parameter and x is variable. So put the notation for that I of a. Limit 0 and infinity are constant. So apply the DOS rule 1 and use the steps. Show that the answer is equals to this. And assume that integral 0 to infinity e raised to minus x square dx is equals to root pi divided by 2. Similarly, the next question, prove that integral 0 to infinity e raised to minus alpha x sin x upon x dx. Here this function is to be integrated with respect to x. So x is variable and alpha is parameter. So put the notation for this integral as I of alpha, and limit 0 and infinity are constant. So apply the DOS rule 1 to find the value of this integral.